There is a commercial airliner sitting in an aviation graveyard right now, whose wings were designed to warp the fabric of atmospheric physics just to save you 45 minutes on an Atlantic flight. It is a machine that could routinely outrun the rotation of the Earth, yet its existence is defined by a mathematical failure that directly impacts how you fly today. It's an engineering reality that most people find genuinely difficult to believe the first time they look at the data. Stay with me from beginning to end, because structural limitation number 3 is an aerodynamic paradox that textbook designers didn't think was possible in commercial transport. And the final limitation, number 5, is the exact economic law that permanently changed the sky for everyone. The first structural barrier is the high-altitude engine choke. You know the feeling of watching a modern twin jet smoothly climb to its cruising altitude, quietly settling into a steady hum. If you attempted that in this supersonic machine, the engines would literally starve of air and stall within seconds. Data from the original test flights reveals that at Mach 2, incoming air rushes into the engine inlets at over 1,500 miles per hour. Because no jet engine can ingest supersonic air without self-destructing, engineers had to design a series of internal geometric ramps that drop down inside the intake to violently slow the air to subsonic speeds in just a fraction of a second. What this means for your flight is that the aircraft was constantly fighting its own speed just to keep its engines breathing. The sheer, brutal engineering required to pull that off, if you let the physics land, is staggering. The second barrier is the low-speed wing trap. Imagine sitting by a window seat during landing, watching the massive, complex flaps unfold from the wings to catch the air and slow the plane down safely. On this delta wing aircraft, those flaps do not exist. To slice through the sound barrier, the wings were forged into a solid, sweeping triangle. At low speeds, this geometric shape generates almost no conventional lift, forcing the aircraft to approach the runway at a steep, aggressive 25-degree angle. Pilots couldn't even see the tarmac ahead of them, requiring the entire nose cone of the plane to mechanically droop down 12.5 degrees, just so they could land without blindly hitting the ground. For the passengers inside, it meant every landing felt less like a standard arrival and more like a controlled rocket descent. The third barrier is the continuous shockwave carpet. You might think an airplane only makes a sonic boom the exact moment it crosses the sound barrier. In reality, a supersonic aircraft drags a continuous, multi-mile wide trail of window-shattering, 110 decibel acoustic energy across the entire planet beneath it. When test flights were conducted over land, the atmospheric pressure waves were so violent they cracked foundations and terrified livestock miles below. This single physical law forced global regulators to pass an absolute ban on supersonic overland flight, instantly shrinking the aircraft's potential global route map by over 80%. It was permanently trapped over the ocean, banned from ever serving normal domestic routes. The fourth barrier is the idling fuel paradox. Think about the standard weight on a crowded airport taxiway, burning just enough fuel to keep the air conditioning running. This aircraft, however, consumed a staggering 6,700 gallons of aviation fuel per hour. A specific operational audit showed that the Concorde burned nearly 2 tons of fuel, almost 10% of its entire cross-Atlantic payload, before its tires even left the tarmac. What this means for aviation geometry is an unsustainable ratio. It required the fuel burn of a 400-passenger jumbo jet while carrying only 100 people. The fifth limitation drops the aerodynamics entirely and hits the brutal reality of human economics. A single round-trip ticket eventually climbed to over $12,000. I've saved this one for last because it belongs last. This aircraft didn't fail because engineering stopped progressing. It failed because it asked the world to trade affordability for pure speed, and humanity chose efficiency. The era of the supersonic airliner didn't end with a crash of physics, but with the quiet closing of a ledger. Has an engineering marvel ever made you nostalgic for a future that never actually arrived? What piece of technology from your childhood felt like it was living in the year 2026, only to vanish entirely?